On June 24, 2021, at approximately 1:22 a.m. Champlain Towers South, a 12-story beachfront condominium in the Miami suburb of Surfside, Florida, partially collapsed. 98 people died. This tragic event shocked the world. According to the investigation, a contributing factor is the long-term degradation of reinforced concrete structural support in the basement-level parking garage under the pool deck, due to water penetration and corrosion of the reinforcing steel. Through this tragedy, people gradually realize structural health monitoring as an important technique of protecting the safety of the whole society. However, existing techniques are either intrusive or wireless but battery-powered, which retrieves data with implanted sensors via LoRa. Neither batteries nor wires buried in concrete are the best solutions, so our solution is to utilize piezoelectric transducers, which interconvert electrical and mechanical waves. We cast the EcoCapsules into the concrete. The reader sends a continuous wave to the PZT, which converts it into mechanical vibrations that propagate through the concrete. The EcoCapsule then converts this vibration into electricity again and stores it. The EcoCapsule can then selectively reflect or not reflect the mechanical wave by controlling the short or open status of the logic switch, thereby passing bits 1 and 0 to the external receiver. Now we show the prototype of EcoCapsule. It contains two 3D printed shells, a PZT, and a printed circuit board with the sensor. The PCB is about the size of a $5 coin. Various sensors can be loaded onto it for structural health monitoring. EcoCapsule can be easily assembled with screws. We made EcoCapsules in many different shapes, some with spherical shell structure to better withstand high pressure, and some with semi-capsule structure or button structure to further reduce the volume. We tested the EcoCapsule in real-world concrete. We cast the EcoCapsule into a mold and let the concrete set for testing. The casting process of concrete is mainly divided into mixing, stirring with water, and pouring into the mold. We add water several times during the mixing process to ensure the strength of the concrete. Before pouring the mixed concrete slurry into the mold, we pre-coat the PZT surface of the EcoCapsule with slurry. The purpose is to make the PZT wrapped tightly in the slurry so that it can harvest stronger mechanical waves. In addition to normal concrete, we tested EcoCapsules in a special type of concrete called ultra-high performance concrete, which holds the record for the strongest concrete produced with standard mixing and curing techniques. For better demonstration, we only cast the half shell with the PZT into the concrete, while the PCB is externally connected to both ends of the PZT. Here is the casted concrete with the EcoCapsule and the reader on either side. The reader consists of one transmit and one receive PZT, and the prisms with different incident angles are also required to eliminate the P waves. Now we can see the LED lights flicker, which means that the mechanical energy has been converted into electrical energy and drives the PCB to work normally. On the normal concrete block, we can see through it and observe the casted EcoCapsules with the CT system. First, we show the downlink signaling from the reader to the EcoCapsule, which uses PIE encoding, and we use frequency modulation to simulate amplitude modulation to effectively suppress ring effect. After sending instructions, the reader transmits continuous waves to power up the EcoCapsule. The EcoCapsule controls the open and short status of the logic switch to backscatter. FM0 encoding is used in uplink backscattering. The receiver uses low-pass filtering, DC removal, matched filtering and other methods for decoding. The EcoCapsules can not only backscatter its own ID but also sensor data of all kinds to provide concrete health information to the outside. We envision this battery-free, permanently implanted node could revolutionize structural health monitoring and bring safe smart buildings to the world.